Welcome to the fastest way to learn data structures and algorithms. Today, we are mastering a fundamental tree traversal problem, LeetCode 637, average of levels in binary tree. This is the perfect challenge to sharpen your breadth-first search skills. Let's dive in. The goal is straightforward. Given the root of a binary tree, we need to return the average value of the nodes on each level, in the form of an array. For example, if level 1 has a single node with value 3, the average is 3. If level 2 has nodes 9 and 20, the average is 14.5. We continue this for every level until the tree is fully traversed. Think of this like a floor-by-floor census in a pyramid-shaped building. Each floor is a level of the tree. To find the average age of residents on each floor, we can't just wander around randomly. We must visit one floor at a time, count everyone there, sum up their ages, and divide by the number of people on that floor. Once we finish floor 1, we move down to floor 2, and repeat. This ensures we don't mix up residents from different floors. To implement this floor-by-floor approach, we use breadth-first search, or BFS. We'll use a queue to keep track of the nodes. First, we push the root into the queue. Then, while the queue isn't empty, we record the number of nodes currently in the queue, which represents the size of the current level. We iterate exactly that many times, popping each node, adding its value to a running sum, and pushing its children into the queue for the next level. After processing all nodes in the current level, we calculate the average and add it to our result list. Look at the tree. We have root 3, with children 9 and 20 has children 15 and 7. Initially, our queue has node 3. Level size is 1. We pop 3, our sum is 3, and since 3 divided by 1 is 3, our first average is 3. We push children 9 and 20 into the queue. Now for level 2, the queue has 2 nodes, 9 and 20. Level size is 2. We pop 9, then pop 20. Our sum is 29. Dividing by 2 gives 14.5. We push 20's children, 15 and 7, into the queue. Finally, level 3. Level size is 2. We pop 15 and 7, sum is 22, average is 11. The queue is now empty, and our final result array is 3, 14.5, and 11. In our Python code, we start by handling the edge case where the root is null. Then, we initialize our queue using deque with the root inside. We create an empty list called result. We use a while loop that runs as long as the queue has nodes. Inside, we capture the level size using len of queue. We initialize level sum to 0. Then, we run a for loop for the range of level size. We pop the leftmost node, add its value to level sum, and if it has a left or right child, we append them to the queue. After the for loop, we calculate the average by dividing level sum by level size, and append it to our result. Finally, we return the result array. For time complexity, we visit every node in the tree exactly once, so it is O of n, where n is the number of nodes. For space complexity, we use a queue to store nodes at each level. In the worst case, the queue will hold the maximum width of the tree, which is O of m. And that is how you calculate level averages using BFS. Mastering level order traversal is a key building block for more complex tree problems. If this explanation helped, hit that like button and subscribe to Leo Academy for more premium DSA content. See you in the next one.